Hello, beautiful people. Today we're going to be talking about 4.6 operations with complex numbers. The imaginary unit I is what we'll be using today. Sounds complicated, but it's not. The definition of I is the square root of -1. So anytime you have the square root of a negative number, in the past you would have had to say no solution. Now, instead of keeping that negative on the inside, to get rid of it, we'll just pull out an I using this definition. Notice if we square both sides of this equation, then we'll get I squared is equal to the square root of -1 squared. Remembering that the squared and the square root cancel out, so I squared will equal -1. Two things I need you to memorize. Number one, I is equal to the square root of -1. And number two, I squared is equal to -1. Here's the property, which basically is saying what I just told you. If r is a positive real number, then the square root of -r is equal to I times the square root of r. See what we did there? We just took out an I, and now this r is positive. Similarly, if we have I radical r squared, it's the same thing as writing, and they don't show you here, but I'll show you the steps. It's like having I squared times radical r squared. Remember that the squared and the square root cancel out, and I squared is -1 times r. That leaves us with just -r, which is what they had right here. Same thing follows here. Square root of -5 is I square root 5. Pretty simple. Here, similarly, do the same thing that we just did here. So I squared times square root of 5 squared. Remember, I squared is -1 times, these cancel out, times 5. So your result is -5. Sounds like fun? Looks like fun? Let's continue. Okay, complex numbers. Before, all that you've learned about before was just real numbers, only the real. You had your positive numbers, you had your negative numbers, you had your fractions, you had your decimals, you had your irrational numbers like pi as well. All of these can be written as a, that being the number that you're used to seeing, plus 0i, because we've never seen the I before. It's imaginary. So complex numbers in standard form are written as a plus bi. Always, always, always put the I term last. A plus bi, where a is the real part and b is the imaginary part. Each of these numbers you can place in the categories that you'll see to the right. So 3 plus 2i. So before we do that, let's review. Real numbers, we've seen them. Imaginary numbers, standard form a plus bi. That's what these would look like, or 5 minus 5i. The pure imaginary numbers would be 0 plus bi. So that means there's no real part. It's purely imaginary. That would be like -4i and 6i. So 3 plus 2i would go in this category that I just messed up. And I'll go back one screen so I can get that right for you. So that 3 plus minus 2i is going to go into the imaginary numbers category. Slight edit there, just kidding. So 3 plus 2i. This -5i, because there's no real part, will go into the purely imaginary category right over here. The 10 is a real number. We're used to seeing those all day. And then I squared. You would think it's going to go somewhere in the imaginary part because there's an I attached to it. But remember from the previous slide, I squared is equal to -1, which makes it a real number. That's your introduction. That's probably the hardest part of this lesson. From here on out, what you're going to do is mostly what you've done before, and that is to combine like terms. This whole entire paragraph here just is basically telling you combine like terms. So if it has an I, keep it with the I. If it doesn't, keep it with that doesn't. So if you were combining like terms for this one, you'd have -1 plus 3, which is not 4, 2, and then 2i plus 3i plus 5i. There's the real, there's the imaginary. That is my final answer. Yep, it is that simple. For the next one, I believe that there was supposed to be another parenthesis right here. So if I'm going to combine like terms, I'm going to have 2i. Because this is a minus sign, I'm going to put minus 3 minus I. Just distributing, not the new part. This is the substitution as well. Plus 2 minus 3i. Now the next thing I'm going to do is combine like terms. So 2i minus I is 1i. 1i minus 3i is negative 2i minus 1. This would give you some credit, but to get full credit, you need to put the real part first and take the imaginary part last. And there you have it. Now, to multiply complex numbers, it's the same thing that you've done before, where you've had to FOIL and where you've had to use the distributive property. The only thing that you need to look out for here is when you have an I squared, because remember, I squared equals negative 1. It's like multiplying by a negative number. It changes the sign. It changes the sign. So let's distribute here. So we have 3i plus I squared. So that gives me 3i. Remember that I squared is equal to negative 1, so minus 1. This is almost good enough, but remember to put the real first, plus 3i. And there's your final answer. For number 4, because I have a binomial, meaning 2 terms times a binomial, 2 terms, I'm going to use FOIL. This is a nice little blast from the past. FOIL, first times first, so 2 times negative 6, that's negative 12. Outer would be 2 times negative 2i, so that's negative 4i. Inner would be 3i times negative 6, so that's negative 18i. And then last, that's 3i times negative 2i, so that's negative 6i squared. Let's do some simplification. This is negative 12. Minus these 2 terms combined will be negative 22i minus 6 times negative 1. Simplifying a little more, I have 12 minus 22i. Get the evaluations. And then negative plus 6. Notice this I squared basically just changes this from minus to plus. Negative 12 plus 6 is negative 6 minus 22i. I'm in standard form, so that means I'm good to go. What's next? So in our previous lesson, we learned about conjugates, how a plus radical b has a conjugate of a minus radical b. Same thing here, except now instead of having square roots, we have I. So what we're saying here is that a plus bi and a minus bi are conjugates of each other. That means when I multiply them, I should no longer have any I terms, no more imaginary parts. So if you remember that special product, which I keep on telling you to remember, I'll write it here one more time, well, probably 4 more times in my life, minus bi. And we will remember that this is equal to a squared minus b squared. Same concept here. A squared minus ai squared. That's a squared minus b squared times I squared. What does that I squared do? Well, remember, it basically just changes the sign because it's like multiplying by negative 1. So this would be like a squared plus b squared. Those are conjugates. So, for this set of problems, they're asking us to multiply each expression by its conjugate. So the conjugate of 6 plus 3i will be 6 minus 3i. If I use my special product, which we have here, that's going to make my life a lot easier because it will be 6 squared minus 3i squared. 6 squared, you already know, is 36. Minus 3 squared is 9i squared. I don't know why I put that in parentheses. I'm going to erase it. I squared. What does that I squared do? Well, it changes the sign. Change signs. So 36 plus 9 is equal to 45. Notice there's no more complex part for this one. Also, The conjugate of 4i is negative 4i. Reason being because 4i is a pure number, so it's like having 0 plus 4i, so its conjugate would be 0 minus 4i, but we obviously don't need the 0 part of it. So 4 times negative 4 is negative 16 times I squared. Again, with the parentheses in 16. Yes, again, I don't know why. And then what does I squared do? Well, it changes the sign because it's just like saying negative 16 times negative 1, which equals 16 for us. Good job. So when we divide by a complex number, it's the same thing as when we had a square root in the denominator. We basically want to get rid of it by multiplying it by its conjugate. So for s, this would be negative 5i, and on top, negative 5i. Go ahead and use your distributive property, and you'll get negative 10i plus 15i squared. And then on the bottom, you'd get negative 25i squared. What does the I squared do? Changes the sign. So I'm looking at negative 10i minus 15 up top. And this I squared changes the sign, so it's just a positive 25. Okay, that does not look anything like standard form for me. So, first thing I want to do is separate these out into two different fractions. Negative 10i over 25 minus 15 over 25. Next thing I want to do, put the real first. So this is now going to look like negative 15 over 25 minus 10 over 25i, a plus bi. Do I want you to reduce your fractions? Absolutely. So reducing this, I'm going to have negative 3 over 5 minus, dividing both of these by 5 also, I get 2 over 5i. You can hit rewind if you need to see that a little bit more. So how do I get rid of a complex number on the bottom here? Same thing. I need to multiply it by its conjugate, which would be 1 minus I. Take a moment and pause now and then see if you can follow that correctly and get the correct answer. Unpause when you are finished. Did you pause? If you did, then I appreciate that. Check your answer with my answer, which is right here. If you did not, go ahead and pause now and copy down my work, but please make sure that you can follow everything that I did. A couple things I want to point out. Number one, there's two separate fractions. You do need to separate them from here to here because you want it to be in the form a plus bi, to where I can see your real and your imaginary parts. Thank you so much. Next. Solving quadratic equations now. So you already know how to solve this as it stands. First thing you would do is minus 26, and then you'd get 2x squared is equal to negative 36. Next thing you do is divide by 2, and you'd get x squared is equal to negative 18. Remember, to get rid of this squared, you take the square root of both sides. So you get x is equal to positive or negative. Now, I'm going to break this down. This is like negative 1 times, what's the perfect square that goes into 18? 9, kind of like Dora because you're kind of talking to the screen, times 2, plus or minus. Well, the square root of negative 1 we know is I. Square root of 9 is 3. Square root of 2, we don't know. This would be almost perfect. The only thing left that I need to do is write it as standard form. That means I want the I last. Well done. Ooh, that's the end of our story. Thank you so much for joining us, and I'll see you all when we return to class. Thank you so much. Bye-bye.